Hello, welcome to the video. We're gonna do a question from the mechanics syllabus involving a particle that's moving along the x-axis. So this question is in one dimension, and the question reads: if a particle moves along the x-axis passing through the origin, so this is the origin and the particle moves along the x-axis, and we define the x-axis to be in that direction, and it's got a speed of 3 meters per second in the positive x direction, and this is our positive direction. Then at time t seconds after passing through this origin, which we're going to call O, the acceleration of the particle is given by 2t minus 1 meters per second squared. So the question says in part A, find the speed of the particle when t is equal to 4. So we need to find the speed, which we're going to call v, of the particle at t equals 4 seconds. Excuse me. So we need to use the relationship between acceleration and velocity. So normally you would say that if x is the displacement, then dx by dt is your speed or your velocity. We don't care too much about vectors in this question, and if you differentiate that again, you get d2x by dt squared, which is equal to the acceleration, or you can just write it in terms of v, just dv by dt is equal to your acceleration. Therefore here, since we have the acceleration, we want to go backwards towards a velocity, finding a velocity as a function of time. We need to integrate the velocity with respect to time. So to integrate this expression here. So in other words, if we want to find the velocity, we need to say that the integral of dv by dt with respect to dt is equal to v as a function of time, which is what we're looking for. Another way of expressing the same thing would be to say that the integral of a with respect to time is equal to v as a function of time. So we're going to use either of these two, they're the same thing. Here we have the acceleration as a function of time, so this is what we got to integrate here. So let's use this one, integral of a dt. So the integral of a dt is the integral of 2t minus 1 dt, and that equals t squared minus t plus the constant of integration. Now this is our expression for v. V is equal to the integral of a dt, and we really need to know what a is, because otherwise we won't be able to find exactly the what v is, what the speed is after 4 seconds. We can't put 4 in here yet because we don't know what the a is. So the way we normally find out the constants of integration is that we look at the initial conditions that they give us, and normally it comes out of there. So they tell us that at time equals 0, the velocity is 3 meters per second. So we can say that v at t equals 0 is equal to 3. And therefore, since v is equal to t squared minus t plus a, then at t equals 0, that's 0, this is 0, and we're left with a. So the 3 then is equal to our a. And so we have a full expression for our velocity now, which would look like t squared minus t plus 3. And now we can say, okay, if t is 4, then I put the 4 in here and I get 4 squared minus 4 plus 3. It's a bit of a strange 3. And that gives us, let's see, 16 minus 4 is 12, plus 3 is 15. So our velocity after 4 seconds, or speed after 4 seconds, is 15 meters per second. Now that was part A, and in part B they ask us to calculate the distance of the particle from O after t seconds. So this is the same exercise we just did, but with displacement instead of velocity. So we need to now convert from acceleration. We've already converted to velocity, and now we need to convert from velocity to displacement. So that we would do by integrating the expression for velocity. So here we had calculated that v was equal to t squared minus t plus a, and the a had been 3, so we can just put 3 here. Don't need to write it like that now. Plus 3, and we're gonna have to integrate that. So excuse me. Okay, we're gonna have to integrate that in order to get our x, because v is the same thing as dx by dt. They're the same thing. So if dx by dt is t squared minus t plus 3, then x will be equal to the integral of dx by dt with respect to time, which is equal to the integral of t squared minus t plus 3. With respect to time. Super important, we always include this here. So let's see, t squared, that is integrated to 1 with 1 more power, and we need to divide by 3, so that then if the 3 came down upon differentiating, it would cancel with this third, and then you will have only 1 t squared, which is what we have up here. Here is the same, we have power goes up, we need to divide by 2 to balance, and the 3 goes to a 3t, but we also have a constant of proportionality here. But when we look at the displacement at time t equals 0 away from O, the displacement is 0, the distance is 0 from the origin, because that's where we're starting from. So if we put here t equals 0, we should get 0 on the displacement, which is our x value. So this a here, if we put everything equal to 0, the a equals 0, so then this goes away, so we don't need the constant of integration. Can just cross it out. So that in part B, since we were asked for the distance away from O at time t seconds, then this is our answer. That's how many meters away it will be after time t seconds. If you put in here the time, then you get t cubed over 3 minus t squared over 2 plus 3t. So that's our expression for part B. I don't know if I labeled it here, but it's probably a good idea. B. Now, in part C, it says find the distance. Let's do it here, a bit more space. Find the distance traveled by the particle between the instants when t equals 1 and t equals 3. That we're gonna do in the next video, because I'm nearly up to 10 minutes now, and I think that's gonna be the limit for the videos. So see you in the next one.